Okay, moving on to problem number 7. Okay, number 7 reads, Mr. Apostle wants to create shelves for his classroom that are 1 1/3 feet long. So the shelves are 1 1/3 feet long. How many shelves can he put in his classroom if he uses an 18-foot board? So if he has an 18-foot board, how many sections can he make of 1 1/3? So there, if you go ahead and draw this diagram, you should already know that which order of operations are you going to use. If you're going to cut this up into sections, if you're going to divide this if you're going to divide this 18-foot board, what order of operations are you using? You're using division. Okay, so I could use 18 divided by 1 1/3. Or even simpler, I could turn this into decimal and go 18 divided by 1.3. Okay, whichever way works for you best, go ahead and do that. Okay, whichever way you think works for you, just go ahead and do it that way. Okay, in my particular case, I'm gonna go ahead and do it through fraction, just so that I could show you again how to divide fractions. But if you just do this on your own, you should get the answer. Okay, so 18 divided by 1 1/3. First, I'm going to turn this mixed number into an improper fraction. So I go 18 divided by 4/3. Then I'm going to do copy, change, flip. First, let me copy that on the palm. Then I'm going to copy, change, and then I'm going to flip it. So I have 18 times 3/4. I can't multiply a whole number times a fraction, so I got to turn them both into fractions. Then I'm going to multiply straight across. So I'm going to end up with 18 times 3 divided by 4. Go ahead and work that out on your own. It's 54, and then you just go ahead and divide that. How many times does 4 fit into 54? It fits in It fits in 13 times. Okay, that's gonna give me 52 with 2 out of the 4 left over. Simplify that, and it's 13 1/2. Now, I want you to refer back to a question. It says, how many sections can he cut? So obviously, if I'm going to cut sections, I'm only going to be able to cut 13 sections. Okay, so my answer would be 13. Okay, thank you very much. Go ahead and you want to check it with dividing the decimal, you can do that. Okay, thank you very much. Okay, so I'm going to start working on problem number 8. Problem number 8 asks, Mr. Alvarado bought a CD for 40% off the regular price of $21, not including the tax. The next day it was on sale for 70% off regular price. How much money would he have saved if he wanted to buy a CD? So the problem says he bought one for 40% off, but then it went on sale for 70% off. And you're trying to figure out the better deal. Okay, well, the CD cost original $21. You gotta figure out how much did he pay here and how much did he pay over here in 70%. Okay, so I'm gonna calculate how much is 40% of 21 and how much is 70% of 21, so I know how much the discount was. Okay, so I'm just gonna go the really fast method, which is turning it into decimal. So in this case I go 0.4 times 21. Here I go 0.7 times 21. Go ahead and calculate that on your own. So 0.4 times 21 is 8.4, and 0.7 times 21 is 14.7. Again, guys, this is where a lot of people get confused. A lot of people think that that's your answer. This is just a discount. So you got to label it. The discount was 8.4, but that's not how much you paid. She paid the subtraction of 21 minus 8.4. Okay, so tell me how much she paid when she bought it at 40% off. So she ended up paying $12.60. But if it went on sale later on for 70% off, she wants to know how much money would she have saved if she would have waited. Okay, so again, this is the discount. How much she would have paid is the subtraction between 21 minus 14.7. Okay. Which is $6.30. That's how much she would have paid if she bought it at 70% off. That's how much she would have paid. That's how much she actually paid. So if she would have waited to calculate how much she would have saved, you just got to subtract these two. And in this case, she would have saved $6.30. Okay, a two-part problem. But you gotta lay down the diagram, refer back to the original question. Okay, so that's how you solve for problem number 8. Now moving on to problem number 9, I'm just gonna go ahead and stop it at problem number 9. You're only responsible for 1 through 9. Okay, so problem number 9 reads: according to the Guinness World Record, Tillman the English Bulldog is the fastest dog on a skateboard. If he travels an average of 100 meters in 19.68 seconds, 678 seconds, what is his unit rate? So he travels 100 meters in 19.678 seconds. So another way of rewriting it, okay, is 100 meters per 19.678 seconds. If I wanted to find out how much he does in 1 second, I'm going to have to divide, okay? So I'm going to divide this number by this, okay? So it would look like this: 19.678 divided into 100. Now, it is a little bit of a complicated problem because of the decimal, but you go here, here, here. You go 1, 2, 3, and you just add your zeros, and then it is a big number to work with. Okay, so I'm just gonna go ahead and do it on a calculator real quick, so you get the gist of the problem. If you don't know how to divide by now, we're in big trouble. And the answer was 5.081, something like that. Okay, so the answer is 5.081 meters per second, per 1 second. Okay, unit rate refers to how much can he do it in 1 second or 1 meter, depending on what your answer you want it to be. Okay, but more than likely you're gonna have to divide something like this. Okay, so if you want to find out meters per second, you would do it this way. If you wanted to find out seconds per meter, you would just flip them around. Okay, that's how you would solve for problem number 8. Problem number 9. There is your answer. Thank you very much.